Good morning, grade 9 students. Welcome in our math class. Again, I am Sir Ibarra Baluyot and I will be your teacher for today. Our topic for today is about solving quadratic equation by extracting the square root. The objectives for this lesson are the following. The learners will be able to A. Solve quadratic equation by extracting the square root, and B. Check the roots of the quadratic equation. Before we proceed in our topic for today, let us have first a simple review of your past lesson. The direction is, give the value of the following numbers. For number 1, we have square root of 25. What is the square root of 25? So you have to think of numbers or factors of 25, same factors or same numbers, that when you multiply, the answer is, or the product is 25. So the answer is 5 times 5. We can also have negative 5 because negative 5 times negative 5 is 25, also positive 25. So the answers are positive and negative 5. For number 2, same process. Two same numbers, then when you multiply, the product is 9. So the answer is 3. Positive and negative 3. 3 times 3 is 9. Negative 3 times negative 3. The product is positive 9. So the answers are positive and negative 3. For number 3, square root of 36. So two same numbers or two same products or two same numbers rather, that when you multiply, the product is 36. So the answers are 6 times 6 is 36. And we can also have the negative 6. Negative 6 times negative 6 is positive 36. So the answers are positive and negative 6. For number 4, it is not a perfect square, unlike the first three examples. So for number 4, what are we going to do first is think of two numbers or two factors of 50 that has a perfect square. In this case, the answers or the products are, or the factors rather, are 25 and 2. We chose these two numbers because 25 is a perfect square. So ang kapartner niya ay 2. Since 25 is a perfect square, the value of 20 or square root of 25 will become positive and negative 5. So we are going to write that before the radical sign. So the answer will become square root of 25 is positive and negative 5. And what remains inside the radical sign is 2. So the final answer will be positive 5 and negative 5 square root of 2. Let's have the last one. We have square root of 300. So same process. Think of factors of 300 that has a perfect square. So we have 100 times 3. And 100 is a perfect square. So we can have the value, what is the value of square root of 100? That is positive and negative 10. So we can write that before the radical sign, and what is left inside the radical sign is 3. So the final answer will be positive negative 10 square root of 3. Again, positive and negative 10 square root of 3. Let us proceed in our topic for today. Solving quadratic equation using square root property. So what is a square root property? This is one method that can be used to solve quadratic equations. It states that if x squared is equal to c, then x is equal to square root of c, or x is equal to negative square root of c, where c is a real number. Solving quadratic equations by extracting square root is applicable if the equation is in the form ax squared plus c equals to 0, where a and c are real numbers and a is not equals to 0. So if you will notice, we don't have a linear term for this example. So we can only use extracting square root if there is no given linear term. So let us have examples. Let us now answer the following examples. The direction is solve for the roots of the quadratic equations. For number 1, the given is x squared minus 81 equals 0. If you will notice, we don't have a linear term. X squared is the quadratic term, negative 81 is the constant term. In this case, square root property is the best method that we can use. First thing that we need to do is to place negative 81 on the right side of the equation using the additive inverse of negative 81, which is positive 81. So we are going to add positive 81 on both sides of the equation. It will become x squared minus 81 plus 81 equals 0 plus 81. Negative 81 plus or positive 81, that will become 0. Our new equation will become x squared is equal to 81. Using the square root property, we're going to square root both numbers on the left side and the right side of the equation. So we have square root of x squared equals to square root of 81. We can now cancel 2 and the radical sign. It will become x is equal to positive and negative 9. Square root of 81 is positive and negative 9. So we have two values for x here, the positive number and the negative number. So x of 1 is equal to positive 9, x of 2 is equal to negative 9. Before we accept these two numbers, we have to check the following numbers by substituting the value of x to the original equation. So let us now substitute 9 into x. So it will become quantity 9 squared minus 81 equals 0. So what is 9 squared? 9 times 9 is 81. 81 minus 81 equals 0. 81 minus 81 is equal to 0. 0 is equal to 0. So meaning, we are going to accept 9 as the root of the quadratic equation x squared minus 81 equals 0. But what about the negative 9? Let us check. Let us substitute negative 9 to the equation x squared minus 81 equals 0. It will become quantity negative 9 quantity squared minus 81 equals to 0. Negative 9 times negative 9, that is positive 81 minus 81, it will become 0. They are equal, meaning we are going to accept negative 9 as the root of the equation x squared minus 81 equals 0. So the answers are 9 and negative 9. Let us have now the second example, which is quantity x minus 5 quantity squared equals to 4. Using the square root property, let us now square root both sides of the equation. We have square root of quantity x minus 5 quantity squared equals to square root of 4. We can now cancel 2 and the radical sign. It will become x minus 5 equals to square root of 4 is positive and negative 2. We have to place negative 5 on the right side of the equation. So we can do that by adding the additive inverse of negative 5, which is positive 5. So we are going to add positive 5 on both sides of the equation. We have negative 5 and positive 5, it will become 0, so we can cancel that. Our answer will become x is equal to positive negative 2 plus 5. Again, we have two answers here, the positive number and positive 2 or in the negative 2. So let us have first the positive 2. X of 1 is equal to 2 plus 5, and the answer is 7. Our x of 1 is 7. Let us try the other number. X of 2 is equal to negative 2 plus 5, which is equal to 3. So our x of 2 is equal to 3. So we have two answers. Let us check the two answers if we are going to accept those two roots. How? By checking. So all you have to do is substitute the value of x of 1 to the original equation, which is quantity x minus 5 quantity squared equals to 4. 7, our x will become 7, so it will become quantity 7 minus 5 quantity squared equals to 4. And 7 minus 5 is equal to 2. And 2 squared is equal to 4. If they are equal to each other, meaning we are going to accept that solution, which is 7. Let us try 3. If x is equal to 3, using the original equation, we have quantity x minus 5 quantity squared equals 0. So we are going to replace x as 3. It will become quantity 3 minus 5 quantity squared equals to 4. And we have negative 2. We have quantity negative 2 squared equals to 4. And negative 2 times negative 2 is positive 4. So they are equal. Again, we are going to accept 3 as a solution to the given quadratic equation. So we have two answers. 7 and 3 are the solutions to the quadratic equation quantity x minus 5 quantity squared. Let us now have the third example, which is quantity x minus 2 quantity squared equals to 36. So using the square root property, square root both sides of the equation, we are going to have square root of quantity x minus 2 quantity squared equals to square root of 36. We can now cancel 2 and the radical sign. It will become x minus 2 equals to square root of 36 is positive and negative 6. We have to place negative 2 on the right side of the equation to get the value of x by using the additive inverse of negative 2, which is the positive 2. So add both sides of the equation, the positive 2, negative 2 and positive 2, it is equals to 0, so we can cancel this. And x is equal to positive and negative 6 plus 2. Our x of 1 is equal to positive 6 plus 2, which is equal to 8. Our x of 2 is equal to negative 6 plus 2, which is equal to negative 4. Again, we have to check if we are going to accept the two values of x by checking. So let us substitute 8 the original equation. So x will become 8. So our new equation will become quantity 8 minus 2 quantity squared equals to 36. 8 minus 2 is 6. And 6 squared is 36. So 36 is equal to 36. we are going to accept 8 as a solution to the quadratic equation. What about the next number, which is negative 4? Again, substitute the value of negative 4 to x. It will become negative 4, quantity negative 4 rather, quantity minus 2, quantity squared equals to 36. It will become negative 4 minus 2, negative 6. Negative 6 squared is equal to 36. And 36 is equal to 36. They are equal, so meaning we are going to accept also negative 4. So the answers are 8 and negative 4 are the solutions rather, to the quadratic equation quantity x minus 2 quantity squared equals to 36. Let us have number 4. Quantity x plus 5 quantity squared minus 3 equals to 1. First thing that we have to do is place negative 3 on the right side of the equation using the additive inverse. The additive inverse of negative 3 is positive 3. So we are going to add positive 3 on both sides of the equation. Negative 3 and positive 3 is equal to 0. So we can cancel this. Our new equation will become quantity x plus 5 quantity squared equals to 4 because 1 plus 3 is 4. After that, using the square root property, square root both sides of the equation. We have square root of quantity x plus 5 quantity squared equals to square root of 4. We can now cancel the exponent 2 and the radical sign. It will become x plus 5 is equal to positive negative 2. Again, we have to place 5 on the right side of the equation so that we can get the value of x. Using the additive inverse, we have to add negative 5 on both sides of the equation. Again, we have positive 5 and negative 5. We can cancel that because that is equal to 0. Our answer will become x is equal to positive and negative 2 minus 5. For our x of 1, we have positive 2 minus 5, and that is equal to negative 3. For our x of 2, x is equal to negative 5 minus 5, and x of 2 is equal to negative 7. So again, we have to do the checking. Let us substitute negative 3 first on the original equation. X will become negative 3. So the answer will become, or the equation rather, will become quantity negative 3 plus 5 quantity squared minus 3 equals 0. So negative 3 plus 5, that is equal to 2. 2 squared is 4. So 4 minus 3 is equal to 1. 1 is equal to 1, they are equal. So we are going to accept negative 3. After that, negative 7. Let us substitute to the equation. X will become negative 7. It will become quantity negative 7 plus 5 quantity squared minus 3 equals to 1. Negative 7 plus 5 is equal to negative 2. It will become quantity negative 2 squared minus 3 equals to 1. Negative 2 times negative 2, that is positive 4 minus 3, and that is equal to 1. So they are equal, meaning we are going to accept negative 7 also. So the answers are negative 3 and negative 7 are the solutions to the quadratic equation quantity x is 5 quantity squared minus 3 equals to 1. Let us now have the next example. X squared minus 71 equals to 4. We have to place negative 71 on the right side of the equation using the additive inverse of negative 71, which is positive 71. So we have to add positive 71 on both sides of the equation. After that, negative 71, positive 71, that is equal to 0. So we can cancel that. And x squared is equal to 4 plus 71. And 4 plus 71, the product, or the sum rather, is 75. Using the square root property, square root both sides of the equation, square root of x squared equals to square root of 75. We can cancel the radical sign and the exponent. But what about square root of 75? How can we simplify that? Since 75 is not a perfect square. So you have to think of two factors of 75 that has a perfect square, and that is 25 and 3. We can get the square root of 25, which is positive and negative 5, and we can write that outside the radical sign. It will become x is equal to positive negative 5 square root of 3. Our x of 1 is equal to 5 square root of 3, and x of 2 is equal to negative 5 square root of 3. Again, we have to do the checking before we accept the two answers. Let us now substitute 5 square root of 3 on the quadratic equation. X squared minus 71 equals to 4. So we are going to replace x as 5 square root of 3. It will become quantity 5 square root of 3, quantity squared minus 71 equals to 4. So we are going to square both 5 and square root of 3 because we have an exponent 2. So square 5, 5 times 5 is 25. After that, we can cancel 2 and the radical sign. And we have 25 times 3 minus 71 equals to 4. Again, quantity 25 times 3, quantity minus 71 equals to 4. The product is 75 minus 71 equals to 4. The difference is 4, and that is also equal to 4. So again, they are equal. We're going to accept 5 square root of 3 as the solution to the quadratic equation. What about the negative number, negative 5 square root of 3? Same procedure. Substitute the value of x. X will become negative 5 square root of 3. We have to square negative 5 and square root of 3. It will become negative 5 times negative 5, that is 25. Square root of 3, we can cancel 2 and the radical sign. And proceed to multiplication. Quantity 25 times 3, quantity minus 71 equals to 4. 25 times 3, the product is 75 minus 71 equals to 4. 75 minus 71 equals to 4, and that is equals to 4. Now, we can now accept negative 5 and square root of 3 also as the solution to the quadratic equation. So the answers are 5 square root of 3 and negative 5 square root of 3. Let us now have the next example. We have x squared plus 20 equals to 4. We have to place positive 20 on the right side of the equation using the additive inverse. And the additive inverse of positive 20 is negative 20. So we have x squared plus 20 minus 20 equals to 4 minus 20. 20 minus 20, we have 0. So we can cancel that. X squared is equal to 4 minus 20, that is negative 16. After that, use the square root property. Square root both sides of the equation. We have square root of x squared equals to square root of negative 16. We can now cancel the exponent 2 and the radical sign. What about the right side of the equation? Do we have square root for negative 16? If you are thinking positive 4 and negative 4, let us check. 4 times 4 is 16, so that is not negative 16. And if we try negative 4 times negative 4, that is also positive 16, and that is not negative 16 as the product. So what are we going to do? Think of the factors of negative 16. So we have square root of 16 times the quantity negative 1. After that, we can get the square root of 16, which is positive and negative 4. And what is left inside the radical sign is negative 1. And negative 1 inside the radical sign is another number. And we can change that as imaginary number. So how can we change that? I have here, if we have square root of negative 1, and that will be equal to I as an imaginary number. So our answer will become x is equal to positive negative 4i. Our x of 1 is equal to 4i, and our x of 2 is negative 4i. Again, before we accept these two roots or two solutions, we have to do the checking. Let us now substitute 4i as x. It will become x squared plus 20 equals to 4. Substitute quantity 4i, quantity squared plus 20 equals to 4. Square 4 and I, we have 4 times 4 is 16. 16i squared plus 20 equals to 4. After that, what will be the value of I squared? So we have, again, as I have said, quantity or square root of negative 1 is equal to I. If we are going to square both sides of the equation, we have square root of negative 1, quantity squared, and we have I squared. We square both sides of the equation. Nilagyan natin ang exponent. After that, we can cancel the radical sign, and we can also cancel the exponent 2. At ang matitira na lang ay negative 1. So negative 1 is equal to I squared. So if we have here I squared, 16I squared, we can replace I squared as negative 1. So we have 16 times negative 1 plus 20 equals to 4. 16 times negative 1, the product is negative 16 plus 20 equals to 4. And we have 4 is equal to 4. They are equal, so again, we can accept 4i as a solution to the quadratic equation x squared plus 20 equals to 4. What about the negative 4i? Same process. We have to replace or substitute negative 4i sa x. We have x squared plus 20 equals to 4. Do the substitution. We have quantity negative 4i, quantity squared plus 20 equals to 4. Again, square negative 4 and I. Negative 4 times negative 4, positive 16. And we have I squared. So 16I squared plus 20 equals to 4. So same process. 16 times negative 1. As I have said, I squared is equal to negative 1. So I squared will become negative 1 plus 20 equals to 4. 16 times negative 1, that is negative 16 plus 20 equals to 4. And negative 16 plus 20 is 4. We have 4 equals to 4. So now we can accept negative 4i as a solution to the quadratic equation x squared plus 20 plus 4. So the answers are both x of 1 and x of 2 are the solutions. Meaning 4i rather, and negative 4i are the solutions to the quadratic equation x squared plus 20 equals to 4. Always remember x squared is equal to k in square root property. But if k is equal to 0, we can only have one solution. If k is greater than 0, two solutions. We are going to have two solutions. And if k is negative 0, just like in our example, we have square root of negative 16, that is less than 0. two non-real solutions or imaginary numbers rather, are the solutions. You have to take note of this. So you will be guided for your answers. That will be all in our topic for today. For your activity today, answer in Module 2. The title is What's More on page 6. And I will send a link in our Google Classroom on how you are going to pass your answers or your answers in your activity. Once again, this is Sir Ibarra Youth. See you again in our next lesson. Goodbye, everyone.